So here we go, 7-6. So we talked a lot about polygons. This is not considered a polygon, all right? It's a shape. It's basically it's the only shape we've talked about up to this point that's not a polygon. Everything else we've talked about are polygons, so this one is not. We are going to talk about, let's see, pretty sure. Not quite. Now, I will tell you this. You guys don't do what I ask you to do, but I'm going to tell you, you got to do it anyway, all right? The last part of section 7.5 that I did not teach. Remember that? There was like one little part at the end of section 7.5. It's on last year's YouTube, all right? So look at 7.5, and you're going to talk about some of the words that we're going to talk about today, at least one of the words we're going to talk about today. So it's imperative that you watch that video, take some notes on it, all right? You're big kids now. You're honors kids. I know you hate hearing that. I'm saying it anyway, all right? You're honors kids. I expect when I say, all right, we didn't have enough time to finish section 7.5, so tonight for homework, I want you to watch it, okay, and then do the problems. If I say that, I expect you to do it, all right? It's not just a blow-off thing. Well, he just said to watch it. He doesn't really mean it. He's just going to teach it anyway. Nope, not going to teach it, okay? Everybody understand that, right? And it could be on the test. So watch it, okay? Take notes on it. Make sure that you understand it. Okay, enough said. Let's do section 7.6. We've got two formulas that we're going to talk about briefly. These are formulas that I can almost promise that you've done before, probably in middle school, I would guess. All right, so C, what do you think C stands for? If I'm talking about circles, what do you think? Yes, it's the circumference of a circle. Have we done that before? Have we done circumference? It seems like we did. We didn't do anything with circles at all? It seems like we did something with circles. We may have talked about it. I don't know. If not, it's okay, because we're going to talk about it today from scratch, all right? The circumference of a circle. So if I was to draw a circle right there, and I'm going to actually just do this. I'm going to put a dot right there. That's an important dot. And I'm going to put something else. I'm going to put that right there. Oops. What did I do? Oh, I know why. Because I clicked on those words. That's why my writing went away. Let's try this now. Okay, there we go. All right, so let's talk about this. What does it mean to be this to find the circumference? Well, the circumference is, let's say you started right here, okay? I'll put a little X right there. And then if you were to go around, now I'm not going to be super accurate. That's not half bad, actually. If I go all around that entire circle, I walk around the circle, or the what? We did talk about this earlier in the year. If I go around an object, what am I finding? I'm finding the what? The perimeter, right. So the circumference is basically what? The perimeter of a circle. That's right. So if I say the circumference, I'm talking about the perimeter of the circle, walking all the way around the circle. Not going through it. Okay, I'm not finding out how many squares can fit in it. What am I doing? I'm walking all the way around it. It's the perimeter, the distance around. Everybody got it? So that's how I usually define it, as the distance. And I just stop right there and say distance around. Around the what? The circle. Okay? We keep circumference for circles. Everybody got it? We don't use it for a rectangle. We don't use it for any kind of polygon. We just use it for a circle. So it's the distance around. So let's take a look at this little formula. Circumference, the distance around the circle, is 2. We know what 2 is. Times pi. I think we talked about pi earlier in the year, didn't we? When we talked about perimeter. Yeah, I think we did talk about perimeter of a circle. Yep. So what is pi to 2 decimal places? So I'm going to put a little squiggly equals. Why did I put squiggly equals, not regular equals? It's approximate. That's right. It's approximate, what? 3.14. And it keeps going. I'll put dots here. Pi does keep going. I'm not going to get into pi because we just lost too much time. But we're going to use 3.14. If you put it into a calculator, you'll get some big, long decimal, okay? I do not. Everybody listen to me. Everybody's listening? Zion, you listening to me? Okay. When you put it in, I'm sorry, I should say this, not when you put it into a calculator. You are not going to use the calculator button for pi. There's a button on there. You push it, boom, 3.14159, blah, 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 blah. Like 8 decimal places, something like that, depending on your calculator, okay? I don't want you to use that number. What do I want you to use? 3.14, okay? I want us to be consistent, all right? I want everybody using the same numbers. So don't use the pi button on your calculator. Use 3.14. Everybody got it? Okay. And then R. What do you think the R represents? The radius. And that little line that I drew right there is the radius. It's from where? What do I call that point right there? The center of the circle. So this is the center of the circle, and this is to really any point on the circle itself, okay? So I could have drawn from the center to a point on the circle right there. Tell me something about those two little line segments that I just drew. They're both the what? The radius, and they're both what to each other? Equal to each other. That's right. I could draw a whole bunch of radii. Remember that word? We've talked about that before, haven't I? What is radii? It's the plural of radius, okay? It's the plural of radius. Everybody got it? Okay, enough of that. So if I gave you, let's do we got one more to do, sorry. What's this whole chapter been about? Finding the what? Find the area. So circumference is important, but area is really what we're here to talk about. Anybody know off the top of their head what the area of a circle is? It's something you were taught before, I'm sure. It's pi r squared, exactly right. It's pi r squared. And it makes sense for something to be squared. Why? Because the area is always feet squared, inches squared, centimeters squared. Would you agree? So there must be two numbers that are the same that are being multiplied by itself. You got it? Okay. Look, pi, it doesn't have any units at all. So if it was just pi r, that would just be a distance, right? It would be a length. But area is more than a length. Area is how many what can fit inside that circle. How many squares can fit inside that circle. Everybody got it? Now, you know, since it's rounded and squares are, I don't know, flat, I guess you could say it, just straight lines, okay? You could put a square really, really up close to the circle, even touching the circle, right? But you're going to have some gaps in there, aren't you? Because that rounded part. That's why you're always going to get a decimal, and that's what the pi takes in consideration, all right? So area will always be some kind of a decimal number. So a calculator is of utmost importance to this, so don't come in here and borrow my calculator. You have your own calculator, Connor, right? Get your own calculator and use your own calculator, okay? There should not be any sharing between you. All right, don't say, well, the kid next to me's got a calculator, I just use theirs. No, you should always have your own calculator, especially when you're doing area of circles, because it's too hard to multiply by 3.14 by hand. You could do it, but it's a pain in the butt, especially if you're going to multiply it by a big number, something being squared. You don't want to do that, okay? So let's do that. So, yeah, I'm not going to put equals here. That's good enough. Let's put it in a box, though. All right, so you need to know that formula, and you need to know that formula. I'm not even going to do an example because that's too easy. Let's do something else that you probably have not heard of before, okay? That's what you're here for, right? Learn new stuff. Isn't that why you're here? Nope. I'm here because my parents said I had to be here, right? See, that's just a sign of immaturity. When you get older, and I'm not saying that to put you down. I mean, any ninth grader has definitely a level of immaturity, so I'm not putting you down for it. But when you get older, you're going to look at stuff, you're going to learn things that are great to learn just for the sake of learning it. I promise you. You will get to that point. You may not now, and I get it. I wasn't there, right? I definitely didn't always appreciate, learning stuff when I was in class. I did it because I just wanted a grade. My parents made me go. The law, right? The government makes you go to school. So it's basically why I went. So I get it. I'm not putting you down for it. I'm just saying that when you mature, when you get older, you're going to actually want to learn stuff just because you want to learn it. And that's the joy of education. That's the joy of learning things. It really is. And right now, the word joy and the word learning may not coincide with each other, but when you get older, and you're going to appreciate the fact that you've learned some things. All right, enough jabber stuff. Let's do this. I'm going to put this crazy thing, this crazy symbol in here. It may be the first time you've ever seen it. I'm not really sure. It looks like an O. Looks like the Orioles O, doesn't it? With the O with a little swoosh through it. Anybody see the Orioles symbol? Kind of looks like that. But it's a Greek letter of the alphabet. Okay, this is how I draw it. Some people draw it a little differently, but the Greek letter is called theta. All right. It's called theta, which is a letter in the alphabet, in the Greek alphabet, right? They got alpha, beta, right? You've heard of those words, right? You've heard gamma, you've heard all kinds of lambda, right? When you think of like college sororities and fraternities and stuff like that, they use those all the time. But one of them is theta. Some people say theta. I've always heard it theta, but that's what it is. What we do is a lot of times, not all the time, but a lot of times when you have an unknown angle, instead of calling it just angle B, a lot of times in not just geometry, but in math in general, we use this Greek letter theta to represent an unknown angle. So that's what we usually use theta for, to represent an unknown angle. Okay? Everybody with me on that? I don't even know if they do it in the book, but I do it here. Do you see how I have two radii drawn in that circle right there? And theta is the angle that's between those two radii. Do you see it? Yes? Got a radius here, radius here. This is the one that connects the two radii. Yes? We give this a name. We give that angle right there a special name, and we call it the central angle. It makes sense. All right? Makes sense because it's an angle formed where? At the center of the circle. Exactly. Okay, so that would be considered a central angle. Everybody got it? And the vertex has to be at the center. That's the key to a central angle. The vertex has to be at the center. So for instance, if I would draw like from there and then to there, is that a central angle? This thing right here? No, why not? Because the vertex is not where, I should say. It's not at the center, okay? Everybody got it? All right, so there's another angle we're going to be doing in chapter 8, I believe. Chapter 8 is all about circles. There's another angle. Don't write this down, but there's another angle right there. Do you see that? And where does the vertex lie there? On the circle itself. We're going to be talking about that angle in another chapter, just not here. Okay, in the next chapter, yes. All right, and let's do one more thing. Well, two more things. Let's draw, what do I want to do here? Let's make that white. I'm going to connect A to C. You see that? I connect from A to C. Now, A to C, anytime I connect any two points on a circle, like right there and there, anytime I connect 2 points actually on the circle, okay, I call that thing a chord, C-H-O-R-D. All right, that's called a chord. AC is also a chord, isn't it? Because it connects 2 points on the circle. What about AB? Is AB considered a chord? No. Because B is where? It's at the center of the circle, and it's not where? On the circle. That's right. On the circle means this white part right here. This right here, that point right there, we'll call it point X. That point is not on the circle. Where is that circle? Or where is that point? I'm sorry. It's in the circle. That's right. Where is that point right there? Point Z. It's outside, or it's the exterior, or on the outside of the circle, okay? So you got exterior, you got interior, You got on. See point A? That's on the circle. Point C? That's on the circle. So anytime you connect 2 points on the circle, we call it a chord. But AC is more of a specific type of chord. What it does, it takes that central angle and it connects where that central angle hits on the circle. Do you see it? The central angle comes out to A, comes out to C. If I connect A and C, we call that the segment. Okay? We call that the segment, I guess you could just say of the central angle. Okay? Just say we'll call it a segment. Everybody with me on that? Oh, actually, you know what? I'm sorry. I got ahead of myself. We don't call the line segment a segment. We call something else a segment. Let's do this. Let's forget that just for now. All right? Sorry about that. What I want to do is this. Let's just put this in another color. What if I shaded in, do you see this region? Do you see that whole big angle right there? Okay, so that's shading in, all right? So I'm trying to shade in everything there. I'm just not going to color in everything, but you get the idea. So we call that thing right there, this area right there, we call it a sector. S-E-C-T-O-R. You saw that at the beginning, didn't you? See that? Circles, sectors, and what? Segments. Got to do the sector first. That's very important. Did you have a question? Okay, here. This probably won't help, but this is the definition, but I'll try to explain it. It says the sector is the region, okay, the area, I guess, if you want to call it, bounded, okay, meaning you've got a boundary. What's your boundary? The two radii and the intercepted arc. What does that mean, the intercepted arc? Here's another word that we haven't talked about yet. Do you see from A along to C, not a straight line, but that curve right there? Okay, that curve right there is called an arc, right? And we write AC and we put a little arc. We're going to be doing a lot more with that in chapter 8. Okay, we'll be doing a ton of that kind of stuff, right? But that thing is the arc. Everybody see it? That little white segment from here. I shouldn't say segment. That white line from there to there. Everybody's looking here, not at the goats. All right, so I don't know, but I've got people looking out the window. So from here to here, that's an arc. Do you see the red area that I've shaded in? That's called the sector. So a sector is not a straight line, it's not an angle, it's a region, okay? It's part of a circle, it's a chunk, it's a piece of the pie. Think of it like that, all right? You cut a pie, you'd cut it like this, wouldn't you? The piece of the pie is the sector. Everybody with me? One more thing and we'll be done because the bell's going to ring any second. Just hang on. So let's do this thing. Remember I talked about this earlier? Now the line segment itself is not the sector. Let's change colors. Let's make this blue. Give me just a minute. So watch. You see this area right here? Yeah. Okay. Do you see that region? That blue region right there, that's called the segment. And again, it's bounded by the chord, right, AC, and the arc, AC. Do you see the chord is a straight line, and the arc is like, it's got a bend to it? Yes? All right. So that blue part right there is the segment. The whole entire red part is the, what? Sector. Okay? All right. Well, I don't know how much I've done. But try to do some of these. So 1 to 10, 13 to 18. Okay? So 7, 6, 1 to 10, 13 to 18. You should be able to do most of this. Right, you might not be able to. You might not be able to do 13 to 18 because we didn't quite finish. We'll finish it tomorrow though, okay?